Hello, wait, I didn't realize the game would start immediately. Hold on. The cutscene. There's text. What's happening? I thought there was gonna be like a title screen. What the frick? Okay, there it is. Okay, I guess there's no title screen. We just start. It's weird. Anyway, welcome everyone. It is Monday once again. Hold on. Let me go to my redeems page. Okay, here we are. It's opened. And all right, welcome Defend, welcome Stream Elements, welcome Stanley, Hamp, Slime Molder, Yuyuko, Zoli, Sa, Amplo, Akacetras, Tag Barrel. Yeah, me when the Shen is Zen. Shenzhen IO. Anyway, we're continuing the theme of programming games today. Last week we played Exapunks. This week we're playing this game. Basically the story here is I think we're hired as a person that works in Shenzhen and we're making some circuits or something. I don't know. Welcome Essie as well. I don't know how accessible this is gonna be. Welcome Michael. It's another one of those where, like, if you're not a programmer, you're gonna watch this and be like, I don't know what's happening, dude. He's got like a manual. He's reading a freaking PDF on screen. Programming. Anyway, this is it does expect you to print out a manual, like physically. It's like, hey, print these things out. Put them in a binder and like do this stuff. I'm not doing that. Here's some instructions. We're programming in an assembly-like language. Here's I think the lore is told through PDFs. So it's like we're hired somewhere. Here's a McDonald's. Are they allowed to do this? They can just mention McDonald's. And then I guess the lore of this game is that we are working in China designing circuits. And yeah. They recommend Prime Mover. What's that? Prime Mover. Okay, maybe I'll look that up later. Okay, I don't know. I watched a little bit of Northernlion play this. He played it a long time ago, but I don't think I watched it when it was live. But, you know, before I started this stream, I was like, I might as well look up what the basics of this game are. So let's see, how do we start? How do we actually start the game? Datasheet's concept mail. Write it down. Okay, Prime Mover. I'll open that in a tab. Prime Mover. It's a lot of things. It's like a movie. It's got a Wikipedia article. I don't know. You're doing extremely crappy, unnecessary things. Enjoy programming Wi-Fi connected vape LEDs. I saw there was one where you're making like an esports sign. Anyway, I'm not reading this. What, you think I'm gonna read all of this text? No. Important. Read the manual. Sure. Okay, this one, we're working on a security camera. Here's the gist, okay? I've watched a little bit of what to do here. So basically, okay, this one, here's what's going on. If this doesn't look interesting to you, I don't know what to tell you. We have circuits, right? I don't think I would have understood if I didn't watch someone play this. Basically, what we're doing here, we're writing code, okay? You look at this. This is a circuit of some sort. We have ports, we have registers, we have state, we have whatever this thing is, output ports, I don't know. And then you write code, okay? What we want to do here is to check verification. Okay, here's what we're doing. We're writing signals to output. I don't know if we do anything with network. Oh no, we are doing stuff with network. So basically we have these microcontrollers, right? and we write code, and we want to replicate the signal that's down here. Let me put myself over here. So this one, I guess we're working on like a camera or something. Also, the music sounds kind of low. Can I like, hold on, can I go to the settings, control panel? Music, increase that volume. They got auto formatting of code. You could play this in, presumably that's Chinese, but that doesn't look like Chinese to me. I don't know. All right. Go back here. We continue this one. Okay, so we gotta read the manual. Cantonese? Oh, maybe. Possible. And so what's happening here, right? We have... This is our input, and we're writing things to the output, right? So we have this active signal. We're writing zeros, and then we sleep for some time, and then we write 100. It's 100, right? And then we have another one. How do I add like a second thing here? Power usage. Oh, we have to put this right. We gotta put this here, okay? We have two things. Maybe you could do this with one thing. I don't know. I don't think you can. Oh, we have this one that goes to network, right? So let's focus on this one. We have active, right? This active one. And we gotta check the manual. Is there a way to zoom in? Is this like the maximum zoom? This is kind of like, zoomed out. It's kind of hard to see. Shenzhen is in that region. What? Okay, accidentally connected something to itself. So if we look at the manual and we see the commands that are available, right? Hold on, am I streaming on YouTube? I am streaming on YouTube. Sometimes I forget. Okay, so what we have here, this may look familiar, maybe similar to other games we've played. You can move a value from a register to another register. So here's what I'm going to show you, okay? You can move the value of 0. Sorry, let me just demonstrate this. If you move the value of 100, we have this one register called accumulator, ACC, right? And what we do here, we also got to sleep. That's true. You do have to sleep. SLP to sleep. Sleep for some amount of time. So here's what I'm gonna say. For this one, the active, right? We move 0 because we start off at 0. And then we want to sleep for 1, 2, 3, 4, 5, 6. Sleep for 6 units. And then we want to move 100 to accumulate. Wait, do we have to write something? We have to write something to state. Is it state? Hold on. Maybe I should have understood this more. Does accumulator, is that the value? That's not the value, right? Is it? Now you have to move it to P0. Is that it? Is this true? Do people know? And then you want to sleep for 1, 2, 3, 4, 5, 6, right? You sleep for 6. And then this is gonna loop, right? It's gonna loop around. Let me step this, okay? We start here. We move 0 to P0. And then you sleep for 6, right? And then we get here. We have to move 100 to P0. And then you see this thing is lit. It's literally lit fam. So that'll tell you it goes up. And then you're stepping, and then once you've slept for 6, it goes back and you're moving 0 there. And then it goes down. See, look at that. Simple. So easy. 1, 3, 3, 7. What? Okay, so that's, that's pretty much it. You just keep going, and then that's good, right? Now we want to do something down here. We want to do a similar thing. So this one has no code. Currently it's doing nothing. Oh, lit. I see. So for this one, we want to do something similar. We want to move 0, P0. And then we want to sleep for 1, 2, 3, 4, right? And then we want to move 100. And sleep for 2. That looked like 2, right? Sleep for 2. And then we move 0. And we sleep for 1. And then we move 100 to 0. Right? And then I think maybe this should work, right? So this goes here. It goes up, right? It sleeps for 2 and goes down. Sleeps for 1, goes up. Oh, I messed something up. What did I do wrong? Sleep 2, move 0, P1. I forgot to, hold on. Sleep 2, move 0, sleep 1. And you gotta move 1, right? Hold on. Whenever you do this, step. Right, we go here. And then we move 100, so now it should be up. And then we go 2, welcome Darth Nomad. And then we sleep 2, then we move 0, right? And then we sleep 1, and then we move 100. But it didn't. Why did it not move 100? You have to sleep, right? You have to sleep. This is important. You gotta sleep. You gotta sleep 1. Okay, so this is the gist, okay? You go up, you go down, go up, and then it loops, and then it's that simple. That's all you gotta do. And then you go really fast. It runs through all the test cases, and that's it. How the frick did this guy do it in 3 lines of code? 3 lines. It costed 6. This may look like yen to you, but actually, do you know that China uses the same currency symbol as Japan? Yen. But in China, it's called the yuan. Y-U-A-N instead of Y-E-N. That's true. How did he write it in 3 lines of code? I don't know. Anyway, that's going to be too advanced for me. And then we do some things, and then we kind of just design other things. I'm not going to read this. I don't need to read. I'm just going to do it. The yuan, yeah. Okay, and now this one. Control in and control out. The signal from control in should be multiplied by 2 and copied to control out. So basically we have an input, right? Before we were just writing values. Now we have to read values, right? So we got to connect the wires. Control in, that's not it. That's wrong. Gotta go from P0, right? And then to P1. Now there's X, right? X is different. We're not up to date yet. Basically, we want to read the value from P0. This is where we have the accumulator, ACC. We move P0 into ACC, right? I'm just gonna run this so you can see what's happening here. Let me sleep for 1. Here's what we do. Okay, the input. Okay, what if we just move it down? Okay. Move accumulator to P1. So what this is gonna do, it's going to read and then just write directly to the output. This is not going to be correct, but this is going to show you, right? This value is 25. We're writing 25. And so we have pretty much replicated the entire input. Now what we want to do here, instead of just writing it, we got to multiply. So you look at it and you're like, what can I do to multiply? Well, there's a mul command. That's right. So you gotta mul. Right? Is that true? You unlock more pieces in time, so you can go back and do the first puzzle later. Oh, I see. I see. So what do you want to do? We want to mul R or I. So mul will actually, it affects the value in ACC. So like, it's not like the previous games where like you're multiplying a value with another value. I guess you are multiplying two values, but then the value that you're always working on is this value. So you want to do mul 2, right? We'll read from P0, we'll multiply by 2, and then write the value. Also, welcome, Potato. So we're gonna go. Look at this. Simple. So easy. Maximum efficiency. There's probably a better way to do it. I don't know. Look at that. We're in the middle. Right there. 4 lines. No one has done it better. Okay, there's Laura. Looks good. Thank you. Please enjoy a game. My daughter's learning programming. She created a simple card game. Sure. Wait, win a game of solitaire? I'm not gonna play solitaire. I don't even know how to play solitaire. Okay, right. This game, like many Zachtronics games, has solitaire. Shenzhen IO. What about Shenzhen Europa? I don't know. Welcome, more fish. It's the best part of the game. I don't know. How do I even play the solitaire? Solitaire was good enough they released it. Yeah, they had Shenzhen Solitaire. Okay, this one we gotta make a new thing. Okay, we have new programming to do. Button is a simple input connected to a button. Pulse is a simple output connected to an electronic device. When button is pushed, generate pulses as indicated in the verification tab until the button is released. Okay, so button, we have to go up and down. Okay, every time you receive a rising edge. This is programming, by the way. And by programming, I mean, do you know digital signal processing? I learned this in electronics lab. This is called a rising edge. So when you have a 0, and then you go up to 1, this is a rising edge. So you want to have a trigger on the rising edge. And then on the falling edge, you do nothing. We don't care. So when we receive a falling edge, we want to do write 1, sleep 1, write 1, sleep 1, etc. And then we just repeat. It's possible to use any part in any level, but probably the first 2 levels don't have other parts. In other levels, you can use any part even if it's not recommended. Rising Edge is made by the same people as Tekken? I don't know. No fighting games. Is that a fighting game? Okay, we have many parts. Many of them are not recommended. Take this one. And we gotta read the manual on this though. So first we take button. We put it into T0 maybe? I don't know. It might need to do X0. Let's look at the manual. So basically, what you're doing, this is the thing that teaches you how to make a square wave, you know, move 1, sleep 3, move 0. Oh, this is it. This is the, sort of like what we want to do here. So they have test equal, TEQ is to test whether the current value is equal. And then, you know, like in programming languages, you have like if else. Instead of having if else, you have pluses and minuses. Also, thank you, Yurga, for the 10 months. So the plus means if this thing is true, then do this thing. And also do this thing. And then the minus is like if the previous TEQ was not true, then you do this. Actually, no, this goes to this. I don't know how this works. Does it? This one goes to, if the plus is here, then it does this one. And then it does this one. Otherwise, it doesn't do it. And then you want to sleep. Square waves. I don't know. Alright, so what do we want? Why do we even want to do here? So we would like to read from input, right? We want to move from P0 into accumulator. And then if that value is 1, and by 1 I mean 100, so we do TEQ, right? Test equal accumulator. Do we even need to do that? Can we just read from P0? Guess we could just read from P0. I don't know. But read from accumulator. And if it is equal to 100, Then you can write some pulses. Wait, but then how do we... Oh, we need to store... Okay, the ACC will be... So let's move... Okay, hold on. Hold on. I already don't know what to do here. So if it is equal, we want to store a value that we're currently... But what happens if you press it when you're already in this thing? What happens? Oh, it just goes until you let go. Oh, I see. So the pulse goes until the button is released. So what do we want to do here? Well, definitely want to test, right? Hold on. We could use the accumulator to test whether the button is held. No, wait, what are we doing? I don't know. What if we use accumulator? Could move P0. No, we want to test. Okay, TEQ P0. If P0 is equal to 100, then we want to... What do we want to do? We gotta... Okay, well, let me open the next and duplicate this tab. We have one... We're gonna look at the docs, okay, everyone? This is what this game is about. So what we want to do is... There is a not command. So that'll... What does that do? That will... You want to write P0. What to... what... This is already confusing because we gotta consider time, you know? So we want to move 100 into P1, right? No, we want to... What are we doing? We want to move 100 into ACK. But then we want to preserve the state. Interesting. Interesting. Oh, welcome Nutritious as well. Can't say it's half a button press. No, this is... Yeah, this is like when people say half an A press. What they mean is we have one... The rising edge is one half of the A press, and the falling edge is the other half. So when they say half an A press, it's they only consider this, and then it's held forever. Okay, well, what do we do here? Preserve the state. Can't believe that he would do this. Okay, so you move... If P0 is equal... What if you just, like... What if you just do this? Does this do anything? And then if it's not... If it's not, then you move P... You want to move 0 to P0. No, to P1. No, and then... No, you want to move... Yeah, and then... Hold on. You're gonna understand what I'm doing here. Move... Back... Move... move... Back to P1. And then... Sleep 1. Does this do anything? Hold on. So we start off. There's nothing, you sleep. There's nothing, you sleep. There's nothing, you sleep. Okay, now button is 1. So now you have inverted this. And then you write a value. Look at that. And then the next step, it's still held down. So you invert what's in there. And then you write the value back. And then it goes negative. Oh, yo, check this out. It's not specifically key down. It's specifically key down and not press or key up. I don't know. Okay, no, we got this. Look at this. Okay, and then once it's not held down, it goes to nothing, right? And then we hold it down again. And then it goes back up. And then it does that. Welcome, Crafty Condiment. It does all this stuff, right? Check that out. Okay, it's going, goes up, goes down, Easy. I already figured. Okay, this is wrong. Something here is wrong. Okay, what's wrong about this then? Why, hold on, everyone. Why is this one... Wait, what did I do wrong? Advanced, simulate. Something, okay, I did something wrong there. Gotta move 0. Oh, you gotta move, hold on. No, you gotta move 0 to act. That's my problem. Okay, I was wrong. Okay, maybe you gotta do both. Maybe you gotta move. No, I guess you always move act to P1, right? Yeah. So you get this one out of there. And then you do this. I got it. I know. Alt plus click had the breakpoint. Okay, I will keep that in mind for the next one. Okay, we got the pulse generator. Light up signs. This is the one that I think I saw Northern Lion play. This is the one where you're making an esports sign. See, in this one, we have 4 waves here. We have many inputs, many outputs. So here's the simple one to do, right? You want to, we have no inputs. This is just going to run on a loop. Internet cafe. Is she drinking an energy drink? Anyone know how to read this? This says to add oil. Did you know that? In a literal sense, it means to add oil. But then in Chinese, it's like to work hard or whatever. You know, these are things you learn in society. Okay, so we're gonna work on click 0 and click 1. Okay, so we have P1 goes to click 1. Can you write to P0? Is that possible? You can do that, right? You don't have to read from P0. Got musics. It's one of my favorite puzzles. There's some weird optimal solutions. Oh no. I'm not gonna spend time optimizing. Also, welcome Ikatono. Okay, so what do we want to do? We want to write 0, right? So move 100 to so click 0, click 1 will be P1. Right. No, what if we just did not? Huh? What if we just started? It starts with 0, so we can do move P0, move act to P0, and then not, and then move act to P1, and then not, and then sleep 1. All right, I think that should work. No, it doesn't work. Wait, what? You can't, because it's the same unit of time, so you can't do that. Or maybe I did maybe it's the wrong order. What am I doing? These are half wrong. Okay, so you can't do that. Do you need 2 for this? You can't write in the same unit. Well, I guess you could delay it. Hold on. What if instead of doing this, you just did this? That doesn't work, right? That doesn't work. No, it does work. Yo, it does work. I just wrote them in the wrong order. Okay. You write this one to P1. You write this one to P0. Yo, look at that. So 1 is like the opposite of the other one, right? This one's the opposite. Wow. Okay, so we got that one. Now we got to work on drink 0 and drink 1 and drink 2. So there are also these larger ones you can use. These have more inputs and outputs. I think we're gonna have to learn how to use these X registers, maybe. Possibly. Yeah, outputs are different. Okay, so let's see. What do we want to do? Let's work on drink 0. So you want to move 100 to... Okay, drink 0 is this one. Move 100 to P0. And then you want to sleep for 1, 2, 3, 4, 5, 6. Sleep 6. And then move 0. Move 0 to P0. And then sleep for 4. And then I think it just loops, right? Yeah, okay, so we got that working. Drink 0 is now done. And I guess we could, hold on. For this one, what do we do for this one? Well, if you look at this one, hold on, we could do something with like rising edges and falling edges. And this one, when this goes down, this goes up. And then when this goes up for like 1. And then this one goes, when this one goes up, this one goes down. So we could just have like more components, right? We could just hard code it if we wanted to. That's probably not ideal. Hold on, let me get rid of this one. How do you delete items? Let me just delete this. Here, we could use a smaller one. Use a small one for this. So we can have paste that. Okay, put this one over there. Okay, so they should do the same thing, right? And now, though, now what do we want to do? We want to have this. Is there a way to do that without needing a second one? Probably. But okay, let's do it the hard way. And by hard way, I mean the brute force way. Is we just have one of these components for each one. Right, this one can go here. P0 goes there. So what do we do for this one? You could move 0 to P0. And then sleep for 6. And then move 100 P0, and then sleep for 2, and then no, you want to sleep for 1, and then move 0, and then sleep for 2. This is not the best way to do it, but this is a way to do it. And then you move 1, and then sleep for 1. What does this look like? So that is correct for drink 1. And then you want to do drink 2. Now that one is slightly more complex. Maybe. You could have a third one. Sorry, by a third one, I mean a fourth one. This is not the best way to do it. I simply do not know. The brute force way to do it is to just move 0 to P0, sleep for 7, move 100 P0, sleep for 2, move 0 to P0, sleep for 1, 2, 3, 4, 5, 6, 7. 8. It's actually 8, but what we want to do here is that you want to have a sleep 1 at the beginning, maybe. I'm probably off by 1. Yeah, I'm off by more than 1. Okay, here's what you gotta do. Sleep 1, right? And then no. Maybe you want like a sleep at the end. Sleep 2, move 0. Is this one? Is that what I wanted? Sleep 6. No. Wait, hold on. Okay, that's totally wrong. I'm sleeping too much. Everyone, you are sleeping too much. Do not even sleep that much. I want to sleep for 7. unsleep for 2, 0, and sleep for 6. Oh wait, you don't want to sleep for 6, because then you're sleeping more. This sleep is extraneous. Okay, now we're off. What we want to do here is, you want to sleep another 1. Okay, so that works. It's probably not the best way to do it. It's definitely not that good. But it's somewhere. Now we could consider optimizing this. This could be done a bit better somehow. If we consider the rising edge and falling edge strategies here. So what do we notice about these signals? Well, this one is when you observe a falling edge for this one is rising. Then when this rises, this goes to 0. But then this one, What if we had something for this one? This one here, when there is a falling edge, this one rises. But also, there's other stuff. There's other things that you gotta consider here. But maybe I'll do this at another time. Maybe we'll do this at a different time. We can always come back to this. We don't have to be optimal immediately. I'm just gonna go to the next one. Okay, this one. What is this one? This is as far as I've seen. I have not seen anything after this point. So what is this? What are we doing for this one? Point and foul are simple inputs connected to buttons. Display is an X-bus display output, corresponding to a numeric LCD screen. The counter should keep track of a count starting at 0. Ensure that the display is always showing the current value. When point is pushed, the count should be incremented by 1. When foul is pushed, count should be decremented by 2, but not below 0. What the frick? What is this? Okay, so point is our input, right? And point and foul are our inputs. So what if we just had one simple thing, right? We have an input. What happens if it's a foul? Okay, if we receive a foul, we should not go below 0. If we receive a point, it goes up. For every rising edge, point goes up by 1. For every rising edge of foul, it goes down by 2, but not below 0. I see. And how do we write to... What is this accept? Displays an X-bus display. The heck is an X-bus display? X-bus. Pin 0 sends in 0 or 1 over the X-bus. The X-bus is when it's gonna wait for a value to be received. SLX. What is that? Yeah, the X-bus. SLX. What does that do? The SLX. Okay, it waits for an instruction. So then, okay, let's ignore the foul for now. Let's focus on point. When we receive a point, okay, so this has to go there. When we receive a point, we should increment by 1. This one's gotta go there, right? So we want to read from input. Move from P0, which is this thing, into... no, hold on, we can add, right? We add. Go back up, read the instructions. We want to add 1 every time. So we want to add. So add goes to ACK. So we want to add P0. Right, we want to take this value and then add it to this thing that is what we have. And then we want to move ACK to X1 and then sleep 1. Right, so what this will do, we ignore this for now, this is wrong. But we receive a rising edge, right? It goes up. Is that 100 or 1? I think that's 100. 199. Wait, what the frick? 9. Huh? With the add. Why is this 999? Hold on. Oh, because the signal is 1. There's 100. So we're adding 100 every time? Go there. Okay, we add. Oh, it's 100, and then it goes to 200. What? It goes to 199? Now it's 300? Hold on. I gotta look up how this works. How does this work? X bus values are discrete data packets. Okay. Then what? Let me find some instructions on this display screen thing. Anyway, everyone, you're all like, what's he doing? I don't understand. I'm immediately not understanding. And that's fine. And these things, we have match prototypes, we have instruction sets. We have this weird stuff. We have freaking Dark Lord 555's creepy sound effects page. We have an assembled meat printer primer. Okay, it says primer. I thought it said printer. One page is only in Chinese. Yeah, I saw that one. I'm like, what does it even mean? What the heck is this? Sushi robo. I thought it says sushi. Like sussy. PGA data sheet. I don't know. Okay, this doesn't have instructions on the this display. So what are we sending? How do we send the value? Why is it that when we send it 300, hold on. How does this work? Displays an X-bus display output. Counter should keep track of a count starting at 0. Ensure that the display is always showing the current value. Wait, does push the count should be decrement into... Okay, so we have to... Is this the fact that P0 is 100 and then we have to like... How does this work? Do we just move? Hold on. If we could test... Hold on. Hold on. I just want to check how this works. So we could, hold on. If we write to... let's ignore P0 for now. I just want to check to see how this thing works. If we add one, and then we... What is it called? Put? I forget. If we move accumulator to X1, what does this do? We should see this increment to 1 and then 2, right? And then 3. 2 and 3. Okay, so that's how it works. So the value we write is exactly what gets written. I think there's like a limit, right? It goes to 60. So if we added 100, which is what we were doing. Oh, I see. The maximum is 199. That's why that was happening. Okay. So what we want to do, we have to, like, how do we check this? We want to see if P0 is equal to 100. Then we move. Then we gotta like add. You want to add 1, right? So this is what's gonna happen. Nothing happens. We receive an input. So now this should be 1. Okay, and then we receive another input. And it's 2. Okay. And then it goes to 3, and 4, 5, 6, 7. Okay. Now we have not handled the foul case yet. And so how do we do that? How do we then... I guess we could use this. We can't do that. Is there a way to route the wires so that it goes... It can't go around. How do we possibly... Okay, I guess we need like a better one. One that has 2 inputs, perhaps. So we'll copy this, right? We'll paste that there. Also, welcome Raiders. Hello, Plushy Pixie. Let me shout you out. Streaming retro. PS2 roulette. Whatever it was you were playing, I hope it was good. Welcome Kiara Hime, welcome Plushy, welcome Juzao. The Idol Club. What PS2 games did you play? We're playing this game, which is incomprehensible to pretty much everyone. You might be looking at this and wondering what the heck is going on. And honestly, I don't know. I don't know how to explain this. Or programming though. So many PS2 games. What's the best one? The goated PS2 game. What is everyone's favorite PS2 game? I don't even remember. Party Girls 100%. Never heard of that. But I'm sure it was a blast. Sure it was good times. Actually know this game, I'm not smart enough for it. It is quite confusing. It's like we're taking signals, we're writing things out. It's very confusing. The PS2 has no games. What? It has Final Fantasy something. It's one of those, I don't know. It had racing games. It had Spyro. I guess those are PS1 games. Huh? I don't think I really used the PS2 that much. Definitely played PS1 though. There was a Lord of the Rings game. That was something. Who knows? Anyway, what are we doing here? We want to check if P0, right? PEQ P0. If P0 is equal to 100, then we want to check if it is. We want to check whether AC is equal to 0. If it is equal to 0, then we do nothing. But if it's not, then we gotta sub 2 and okay, I guess we're always moving AC to X3. I don't know what's happening. I just don't know. Just scroll down to your panels and see Yoshimi Ichigo. You're also an Aikatsu fan? Let's go. Final Fantasy 11. I don't even know what else there is on PS2. Not tomorrow. Huge Aikatsu Enduro. That's great. Okay, well. I think this should work, right? No, it does. It turned out it doesn't work. We've somehow gone into the negatives. If AC is equal to 0, Then, wait, how do you do this? How? Because, okay, I see. We don't want to sub. We can't have nested conditions. Is that true? Let me check the instruction manual. This game has a lot of instructions you gotta read. Test greater than. Test less than. Have dat. What about this? It's always about dat, never this. Not sub. Jump. Is there a jump to if equal to? I guess you could here. You could in this one. You could jump. No one has ever played Final Fantasy XI. I feel like I don't really see people talk about Final Fantasy XI. It's always about like 10 and 9 and 7. I don't know. Still confusing me. Okay, how do we do this? If it is okay, so if we have received something from here, can we do like 2 pluses? Is this even legal? It's not even allowed. Welcome, Matthias Avet. Final Fantasy 14. Everyone's talking about that one. How do we nest instructions? Do we have to like move? Hold on. We have to like, if this is here, we have to how does this work? I only want to sub 2 if this thing is not equal to 0. I guess we could just I can't do that. Can you nest? You can't nest things, right? Final Fantasy XI is a PS2 MMO. Oh, that's the MMO one. I see. I don't know. Hold on. How do we do how do we do conditional logic? Can't do multiple conditionals. So this goes there. I guess this thing then applies to this, right? So this is not equal. But how do we have this thing only go to this one? Do we have to add like a jump statement? Loop? Do we have to jump? Mark statement? So we have this. If it's not this, if it's the minus, then we have to go to, I guess this one would be mark. We would mark there. And then if it's not, we would go to jump mark. Otherwise this, right? What am I doing wrong? What did I do? What's happening? Test equals, if it's equal to 100. If it's not equal, go to mark. If it is equal, continue this way. And then you do this. And ACK is not equal, so you don't go minus. But then you go there. I don't get it. 11 was the first MMO. Basically a Japanese EQ clone. EverQuest? I've also never played that. Okay, what's happening? We gotta go up, right? And this one, why is this -1? Hold on, can I go back? Advance. Okay, so now this is rising edge. Oh, wait, hold on. That's why I'm reading from the wrong thing. This should be P. This one should be P1. That's what it is. Okay, now this should work. No, it doesn't work. Hold on. Oh, it has to. Oh, hold on. It has to go below. We have to clip it to 0. So if it is less than or equal to 2, wait, hold on. Well, it's a -2, and then if it's less than 0, it should be 0, I guess. Test equals p0. If it is 100, go there. Otherwise, I guess you could just always sub 2, and then test less than. Is this a thing? TLT? It is. Okay, test less than. If ACK is less than 0, then move 0 to ACK. Okay, so this should work. Hypothetically. Yes, it is going. Also, let me hydrate. It is 6 p.m. Also, why did the music just stop? Did it stop because I'm not editing something? Oh, check it out. I'm doing so well here. I did better than Easy Name. I was able to catch Razul's collab with the Goobers. I watched like a few minutes of it. So, kind of, no. I'm sure it was cool though. Because I beat the puzzle. You're not supposed to stay. What if I'm just analyzing the results? Okay, what is this one? Harmonic maximization engine. Audio in is a simple input connected to an audio source. Audio out is connected to an audio receiver. Maximize is a simple input connected to a switch. The signal from audio in should be copied to audio out. Applying the harmonic maximization algorithm. Look in the supplemental data to find an advertisement featuring the algorithm. What the frick? I had to watch the VOD because it was 3 a.m. I can't believe that you did not stay up to 3 a.m. to watch your favorite streamers streaming. Hecked up, man. Can you be a real fan if you don't stay up? I'm just kidding. Okay, where's the harmonic maximization? Harmonic maximization. Here's the formula. Audio out equals audio in minus 50 times 4 plus 50. Okay. Did stay up to 3 a.m. but had to go to sleep at 3:30. Did you stay up specifically for the collab to watch? It's wacky. Yo, Sunnyvale, that's in California. Any Sunnyvale residents here? Isn't this where Golfland is? Sunnyvale Golfland. Okay, so what are we doing here? We got to apply an algorithm. So while maximize is turned on, we want to run the algorithm. When it's not run, we just want to copy audio in. So what do we do here? You gotta move. You need 2 inputs. Let's not do that. Gotta have 2 inputs. Gotta have audio in. You gotta have maximize. Alright, so maximize is P1. So we want to move P0 to ACK. And then at the end, we always want to write ACK to the output. Where's the output? How do we then write the outputs? Is this, that's not even a thing. Wait, we don't have a regular output. Do we need to have two different devices for this? Do we have to have one that's reading from here and then another one writing to the other one? I can't believe this. Okay, audio in goes to P0. And then maybe we have like a second one. And this one goes to... That's too close. And this one goes to here. Then where does the other one go? Where even does this go? This one, we could write something. Wait a second. What do we do? Okay, let's first consider audio in, right? We want to move P0 to ACK, and then back to P1. But then, oh, I see. We can have this thing. Can this go to X0? I can't. Wait a second. How does that work? How does this even work? Oh, you can use a bridge to go over, right? Is that how this works? This thing gets connected. That's what it is. That's what these are for. Bridges cost no money, just like in real life. Just like that one bridge that collapsed, they cost $0. Alright, so what do we do? How do we do this? We could just move P0 to P1. Right, and that would work for some cases. We're not sleeping, right? You gotta sleep for 1, just like in real life. So now we have slept for 1. But then we want to check whether maximize is 1. And how can we do that? How do we even possibly do this? We have P0. And then if maximized, then perhaps you want P1 to go there. But then then what do you do with this? I don't know. X0. P0. But this one has... Skip these. Get all of these out of here. I don't even want to see these. Get out of there. Okay, this one. We have X0, X1, P0, P1. And this is this. Then how do we do this? I guess we could. Can we write this? That doesn't work. What the heck, man? Does anyone know? Has anyone done this in real life? What's the strat here? We do this. So this one could do that, right? This one, let's put this here. So we want the input signal. And we would like to we would like to, this one should go there, right? So for this one, what do we do for this one? Well, we receive the maximize signal. What if we don't receive? What if we do this? What if that goes there? So what do we do for audio in? We want to move from P0 to ACK. And then we want to check X0. And if X0 is 1, this thing. Okay, hold on. This one moves it P0 to X1. Wait, all this is doing is converting the P pin to an X pin. That's always right. Okay, so we move this, and then we want to check X1. So if X1 is 100, test equal X1 100. If it is, pin is not connected. Sorry, it's X0. X0 is 100. Then you want to run the maximization algorithm. But if not, then you want to jump. So let's go to how do you label things again? Label? How do you label? Labels are okay, it's just a thing and a colon. Okay, so this has got to be mark. So mark, you want to write back to P1. So if it's not that, then you want to jump to mark. Otherwise, then you do this stuff, right? This stuff in here. So how does this work? You gotta run the maximization algorithm. Audio out equals audio in times 50. Welcome, Choco. Minus 50. Sorry, minus 50. And then times 4 and then plus 50. So what do we do here? We got to go to sub 50 mul 4 and add 50. I think this is it, right? This goes. Part is not sleeping. Right, we have to sleep. Gotta sleep one. Hey, look at it, it works. Probably not efficient, but it works. Production cost 8. Power usage, pretty bad. Lines of code, not that great. Alright. That's probably a better way to do it. I don't know. I don't feel like doing the better way. Infrared sensor, important. Okay. Let's do this. What the frick is this? RTC? On time? There's a counter? What? Time is a simple input connected to DT2415 clock. Welcome, Honktown. Time is a simple input connected to DT415 clock, providing the current time. Where's time? I don't see it. I don't see time. Is this time? What is it? DT4501. 4501. I don't even see it. DT45. Oh, 451. Wait, that's the wrong value. 2415. How did I get 4501? What the frick? This broke my brain. Okay, this thing is the clock. I see. It emits a simple I/O signal that corresponds to the number of 15 minutes increments since midnight. It includes a built-in backup battery. Alright. Time index. What is NC? What does that do? Not connected. Is that what it means? Okay. It's not connected. I know. Okay, so this one, it's gotta go. So this is the time in increments of, or divided by 15. Okay. Then sensor is a simple input connected to an infrared sensor. Alarm is a simple output connected to a silent alarm. The current time equals the on time. Device should be armed. The current time equals the off time. Device should be disarmed. Whenever the device is armed and the sensor reads above value of 20, the alarm should be active. What? Time sensor alarm. So time is constantly going up. But it stops at 95 for some reason. It loops back around at 95. Why is that? I don't know. Sensor is a simple input. Well, the current time equals the on time. What the heck is the on time? Current time. Oh, okay. This is like when the sensor is above a threshold for a certain amount of time. What the heck is the on time? Oh, the on and off times are set. Oh, it's right here. The on and off times are set by the operator using dials. It can be read. Welcome, Rune. Okay, so this is the on time. So the person can set this value to equal something. When the time equals the on time, device should be armed. On time. When time equals this thing, should be armed. Now, what does armed mean? Alarm. Whenever the device is armed and the sensor reads at or above a value of 20, alarm should be active. Okay. And current time equals, what the frick? And current time equals the on time. Okay, when the time is equal. Okay, so this one has a value of alarm should be armed. The current time equals the on time. Device should be armed. Okay. Time equals the on time. I don't understand the problem. Hold on. Do I have to like read the lore? Can I read this email? Go back. In the process of setting closer tie-ups with global top firms, infrared sensor, carbon emissions, detecting stuff. I don't know. I don't understand. You know what? Let's... The timer is a clock. Yes, the timer goes up, but then like... Then what? So this is a thing that always keeps going up. When the value reaches that on, so like when the timer reaches 93, then it should be armed. When armed and sensor reads at or above 20, it should be active. But when it equals the off time, oh, I see. This is like, this sets the thing. Hold on. I think I sort of get it. It's a schedule. Oh. So this tells you whether it should alert at all. Like they don't want, okay, so like if this was like an alarm, hypothetically, like let's say you have business hours from 9 to 5. This thing tells you to turn on the alarm from 9 and turn it off at 5. And then when this is active, then when the sensor is above a value, then it should alarm. I see. I get it. Okay, so we have this value is the clock, right? I'm just going to start with this one. So with the clock, you want to read this value. Let's use one of these. I want to read this value, P0. So we have the clock. We want to move P0 to ACK, right? Now we have the clock available here. And then we want to check the clock is equal to the on time. Then you gotta... Then it's on. Okay, then we need something that... we need a thing for whether this thing is on or off. Oh, this is an X0. Wait, what? This is an X... Oh, this changes. Alright, this changes. Lab view. I don't even know. So this one... I guess, do we even need this? Hold on. If this is an X pin, we don't need this. You want this thing to go up here. It's probably a better way to do this wire now. I could probably just put this down here. That probably would be better. Hold on. Get all this out here. Destroy all this. But we also needed one for the sensor. Hold on. Okay, so we have X0. X0 goes to on. And this one go to off. And the clock then has to go to this one. Right. So if X0 is equal... Oh, but X0 only... This will block until... Hold on. X0... If X0 is equal to P0, then we are armed. Then ACK. So ACK will... This thing will tell you whether the thing is armed. So ACK 0. If this thing... If X0... What am I doing? If it is... Hold on. Hold on. The frick. Let's go back here. When time equals the on time, device should be armed. Okay. So, if X0 and P0 are equal, then you want to move 100 into ACK. If X1 is equal to P0, then you want to move 0 into ACK. Right? And now what? So now we know whether it's active. Now we need another thing. And what this thing does is that it reads from the sensor and this thing. And then we gotta move X. We gotta move ACK to... Do we even need ACK? Hold on. Can we just move it? Can we just write directly to X2? We could, right? Right, so then when the time changes, we write this thing. And we sleep 1. And then this one here, the move, I want to compare if sensor. So we got a T, hold on, if X0, if X0 is on, if X0 is 100, then the alarm is off. But if it's not, then you want to go here. Hold on. If it's not equal to 100, then you just jump to mark. But then if it is, then you gotta, and then if P0 is greater than, is it greater than or equal to? I guess it's greater than 19. Test X is greater than 19. Sorry, not X. P0. If P0 is greater than 19, then you will write to the alarm. So you will move 100 to alarm. No, not alarm. P0. Move 100 to P0. Otherwise, move 0 to P0. Part is not blocking. Did it not sleep? Does this not count? Does this not do the sleep? Test equal, test this one. What? Okay, we advance. Part not blocking. It's blocked on read. Can we read from an export without blocking? Is that possible? Return there. You can't even return. It's not even possible, man. Okay, so what are we doing here? Can we, is it not possible to read from the export without blocking? What is SLX? SLX. It waits using the SLX instruction. But what if we don't want to wait? Sleep until data is available to be read. Okay, so it's not. Can't do that. If you return 1. Okay, maybe we don't do this. Maybe this one has to be output here. What if this goes output there? And then we always just return something. What if we had this here? And this one would just always go here. And then we had this one has to turn this into, wait, what am I doing? Okay, X, okay, this one. What am I doing here? Just shout at Macy. Who's Macy? I think this one will just turn this one into X. So we gotta move P0, X1, sleep 1. And this X1. No, but then this is gonna block. Then what am I doing? Let's see. No, this one. No, it's not gonna block. Let's see, I know. Here. This is gonna work. I'm telling you. Look at this. Look at this, guys. This goes up. Not that. That's wrong. Never mind. Everyone, it's wrong. In fact, it's not working. It's actually not working. X1, X0 is never equal to 100. When am I going? Test equal, move 100. If it is equal 93, is it ever equal to 93? Is it on? Time is an input connected to this thing. So that's time. Time is always going up, except when it doesn't. Except when it goes back down. So time is going 38. Information. Yeah, Something's not working. Something is wrong here. Time equals the on time. But what if it's not equal? What does it start off as? Current time equals, hold on, let's read the docs on the incremental clock. Goes up to 95. Oh, we have to divide, I think. Wait, hold on, what is that? Current time equals the on time. No, that's not, no, that's fine. We don't have to divide. I see, this is just every 15-minute increment of the day expressed as a value between 0 and 95. And then, okay, when time equals on time, device should be armed. But like, does it start off as armed? Yeah, there's no value. Do we have to assume that off time is always less than? Is that true? Let me do timekeeping. Got time. 15-minute increments since midnight. And then what? X0 is equal to the current time. Then we move 100. If X1 is equal, it starts unarmed, since otherwise the sensor levels before the on time would have triggered. Starts unarmed. The sensor must be greater than 20. Oh yeah. No, if it's not, then what? And what is this? Why? Hold on. So on time. On and off times are set by the operator using dials infrared X bus inputs. But like what? Then what is this? What goes in on this side? Hold on, what is this? Do they have this part? What is this? Logic gateway. This thing. Just another output. Oh, I see. If this is an export though, when does this fire? Is this triggering every second? It has to, right? Because this is always running. Right, this is always being read. So this triggers every second. Welcome, Ranmu. Okay. Okay, let's advance this. Okay, this starts off. P0 is off. Sorry, wait, what P0? P0 is here. It's not equal. It's not equal. It's not equal. At some point, it will be equal though. Once we get to 93. But why does this thing get triggered before 93? No, because this is. Have a good night, Zoe. It has to start off alarmed. Right. Go here. So it doesn't trigger there. It doesn't trigger there. But at some point, it'll reach 38. Once it reaches 38 over here, but we don't have an example where it triggers after that. Does it go even farther? It doesn't even go. When we do test run number 2, can we change this one? We can't show the test runs. Okay, so maybe we need ACK. Maybe we need to, instead of moving to P1 directly, we need ACK. Move 100 to ACK. No, why would we do that? How do we initialize this thing to 1? I guess we could write the opposite, right? No, that doesn't make sense. The current time equals the on time. Device should be armed. Does it starts off armed? The current time equals the off time. Device should be disarmed. What the heck, man? Current time equals the, it should be armed. But it doesn't start off. It doesn't start off with equal. They don't specify the intermediate values. Forget if you've learned the secret initializer code. Once you start off unarmed, you can probably just assume ACK equals 0 is your unarmed state. Secret initializer code? What is that? To start off armed, you can assume X0 is your unarmed state. Oh, because by default they start with 0. Okay. So, wouldn't ACK0 be our armed state? Okay, if this is equal, then we want to, then what do we want to do here? If ACK equals 0 is the starting state, then we have to check if it is. But then this will run on every loop. What if we had a loop here? This could be the loop. And then we have initializer code, and then this one can go to move. We can start off by moving 100 to P1 and then jump to the loop. That's something, right? So this should fire. It doesn't fire. What am I doing? P0 goes there. So that is 100. That is 100. Now why is that not working? Move P0 to X1. Okay. Hold on. Let's start this over. Step. Okay, this goes there. This is now 100. This starts off active. I do want to start off inactive. This goes there. This goes here. Okay, this goes there. The 100 goes there. Test if equal. X0 is in fact equal to 100. Then I should test this thing. And P0 is not greater than 19. So we should... Wait. Then we move 0, right? That is what we expect. And then we sleep. And then we go. We want to go until it reaches a value of... Wait. Device is armed and sensor reads above 20. Above 20. So 93. It's there. Advance. So now 93. So now what the... Wait, what am I doing? think I'm missing something. Value is equal to 93. 93. It starts off inactive, which is fine. So, oh frick, what did I do? It went too far. Okay, delete all this. Test equal x0. It's not equal. If it is, it's not. Wait. Okay, so now, is it minus, hold on, P0. Check my outputs to alarm. P1. Move a 0. Oh, it's P0. I'm moving from 0 to P0. Oh, what the frick? 1. You can do that. You can just write back to the sensor. No, it's still wrong. Wait, but the first one, I mean, okay, besides the first one, it's good. So I think what I had earlier, this one up here was fine, right? So you want to move 100 to P1, and then this is the loop, and then you want to jump to loop. What the frick? Hold on. The alarm is not on. Wait, why did that not work for this one? Weird things with the bidirectional nature. Wait, why is the first one not working? Hold on. What is this? Stop this. How do I stop? Label not defined. Oops. So like why? Step. Let's go. Step. Okay, the next step. We got 93 into x1. And we have P0 is 93, right? 93 is equal. So it should move 100 into P1. Right. So there should be 100 here. And it is. But this thing has not done it. Because is this like one cycle too late? Is that what the issue is? Is that it? Is that the issue here? Is that this thing? Wait, no, but it gets sent immediately, right? Why would it not work? This is not the case. So we have P1 step. You write 0. Welcome cryptic command. Step. This writes 100. Okay. But this is already on the sleep step. Why is that? Why did it do that? Why do I even have this? Why I can't just... This is a... Alright, because this one doesn't have... Why do I even need this one? This one is simply to convert P to X. But do I even need that? Because like this thing... Oh, because this thing would need to read from the sensor. Do I even need this? Did I just send this to there? Could I move it 2 times? Does that work? Move 2 times in sleep? I guess I could. Hold on. Let me try this. So why did this not work? Because it, oh, because this only changes, wait, hold on. I just like disable this. Here, what does this do? Does this do anything? No. Right, that's why I needed this one. Expressible block. Right now you only sign X if I arm disarm. Okay, so this goes there. And this one's gotta be there. So this has gotta go P0. And this one got to move P0 to X1. What if we do it twice? Move P0 X1. Sleep. This can't be it. Part not blocking. Blocked on right. You can block on right. What the? Maybe I don't sleep. No, part not sleeping. Blocked on right. What? Wait, this is wrong. Wait, what? Move X P0 to X1. Sleep 1. Did I break everything? Oh, this writes to P1, sorry. Simulate. Okay, that's what we had earlier. Okay, what if we did not sleep? Then it would block because it can't. Dude, I don't know. Your problem is thinking you could probably use no-ops to wait until the evaluation to finish. There's no-op do. This instruction has no effect. Then how? But it has no effect. It's got no effect. Does this do anything? It doesn't. It has a temporal one. Do I put where would I put the no-op? Can I put it here? No. Would I put it here? Before the move, since my problem is grabbing the value before you're finished with your TQs. Before this one. Oh, I think I get it. Part not sleeping. I forgot to sleep. No. Do I have to do 2 no-ops? Hey, what the frick? What the heck? Okay, so like even with it, so like these don't execute immediately. They all execute even if you don't sleep. So that's why you need the no-ops. That's kind of confusing that they have sleeps and also these things. Okay, well. But also this is wrong. Something here is wrong. Simple output. Actually. Do I need like a third no-op? Just a third. Do I need 4 no-ops? You think I would need 4 no-ops? Got that one. This one. No, okay, something is wrong though. Okay, we need at least 2 no-ops for something. But what's going on at the end? Why does it not work at the end of this? Pause. We want to put a breakpoint here. How do you do breakpoints? I click this. Can I click here? Profiler. Control click. Control click to toggle breakpoint. How do we? I am control clicking. It doesn't seem to be doing anything. Oh, hold on. That's weird. Let me see. Okay, so we want to put a breakpoint here. Reset and simulate. And then it goes to the last breakpoint. Okay, it stops there. You have the value of 83, which is this thing. The alarm should not be... Hold on, at 83. It's off time. But it's not off time yet. Why does it turn off when it's not equal? It goes to the next one. Step. So test if equal x1 is p0. P0 is right now 84. So it is equal. Then we move 0 to p1. So this should be 0. But now this one... Hold on. But okay, this has already moved before we can execute this one. So what do we do? How do we prevent that? Do we just need more no-ups? Do we just need like... No-up, no-up. Is this good enough? Okay, step. Step. Advance. No, what? Hold on. Simulate. Go to the no. Okay, so we go here. Test if equal x0 is x0 equal to p0. X0 is 48. P0 is 84. That's not equal, but this one is equal, right? Then we step. It's not equal, and now x1 is equal to 84. So that is true. And then we should be moving 0 to p1. Right, we execute this. P1 step. So p1 is now 0. Right. And then we have all these no-ups. And then we move p0 to x1. So we should be writing 0 here. Now we've written 0. And then this one should test if x0 is equal to 100. And it's not. It is not. So we step. It's not equal, so we should jump to mark. Oh, I didn't. Oh, hold on. So if it's not equal, we should be writing 0. Is that what I'm missing? We should be writing a 0. I think that's what it is. And then we go here, but we have not written the 0. Okay. So that is our problem. So let's see. If this is not equal, we don't want to just jump to mark. We want to jump. We want to check. Wait. It's off. We want to write 0. So if it's minus, then we want to move 0 to P1. Right. This should work, but I feel like we could dedupe this. I don't know. This is probably fine for now. Play this, right? Okay, we advance. We step. It goes there. It goes there. Okay, now it's correct. We've done it. It's not even that good, but we've done it. We've used... Oh man, look at this. We're so bad. Hey, my friend didn't even do this one. All right. Oh, that's something. I'm not even going to read your response. I'm just going to work. Just going to go to the next one. The heck is this? Radio RX is a non-blocking X-bus input connected to a radio receiver. Buzzer is a simple output connected to an electromechanical buzzer. When a data packet is received over the radio, read it and execute the corresponding command. When we receive a 0, power off, turn off the buzzer. Yo, this is a freaking VR headset. Okay, so it's radio RX. -999. We want to receive as okay. Radio RX. Okay. So RX is an X bus input. If we receive a 1, we have to start buzzing. Okay, so we want to move. Sorry, if it is equal to. We want to maintain. Okay, so let's move. Let's move X0 into X. Because we want to maintain the last thing we received was 1. So if TEQ, if ACK is 1, then you want to buzz. We need. Okay, we want to convert this digital signal into an analog signal. Rather than 1s and 0s, you want to have like a rising edge and falling edge, perhaps. So I think the purpose of this controller will just be to do that. But how? How do we then do that? Well, what if we if ACK is equal to 1, if it is equal to 1, then move 100 to P1. Wait. You want to no, if it is less than 0, then we want to ignore it, right? So if it's less than 0, if ACK is less than 0, then you want to jump to mark. Otherwise, you want to ACK is equal to 0. That's probably a better way to do this. If it is equal to 0, then you want to write 0 to P1. Otherwise, write 100 to P1. Okay, so now we have this. Now this thing should have rising edge and falling edge. And then we have another controller. Can move that through. We have P0. P0 then goes to here. What if we just did this? Sure, that goes there. This goes here. Okay, so now we have this, right? Now we have this thing that does down. Here, I just want to test what this looks like. Oh, it's delayed. Delayed by 1. So we want to why is it delayed by 1? Is it because of the no ops? Do we need to add some no ops in here? Classic solution, just add more no ops. No, it's not. Maybe even more no ops. I think this is it. It is more no-ops. Okay, so you have you have no-ops. Okay, so now how many? What's the maximum no-ops that we need? That's good enough. 4 no-ops. Can we get away with 3 no-ops? No, we have to have 4. Unless I do it better. I don't know if that's possible. I mean, it definitely is possible. I just don't know how I'm doing it. Okay, so for this one, you want to move this into ACK, and then you want to... No, you want to test if this is equal. Also, let me hydrate. It is 7 p.m. Alright. Welcome Nano Dan. He drinks by the hour. Do you not realize this entire time? Also, why is my Live 2D is stuck? What's the deal? Okay, there it is. Okay, so if P0 is on, we want to... If P0 is equal to 100, then you want to not. Otherwise, want to set it to 0. And then you want to move P0. Sorry, you want to move ACK to P1. Right. Got this one. Oh, yo, look at this, everyone. Totally professional strategies right here. And got it. All you need is 4 no-ops. You just need to have your computer doing nothing at all times. Power usage, pretty high. Production costs, pretty high. Lines of code, pretty high. It's gotta be a better way. I don't even care. Prototyping new ideas. Not even gonna read the lore. I'm just gonna do it. Okay, what the heck is this? This isn't even anything. What is this? I should probably read this thing. What do they want me to do? Set up an empty prototype board for nothing. Objective: design and create an electronic game. No. Let's do this one. Wireless game controller. X and Y are simple inputs connected to a joystick. A and B are simple inputs connected to buttons. Radio RX is a non-blocking X-bus input connected to a radio receiver. Radio TX is an X-bus output connected to a radio transmitter. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure to use the most recent input values. What the frick? X, Y, X, what? How do I interpret this? Okay, we want to send 3 packets, one with X, one with Y, and then one with a value based on whether the buttons are held down. I see. The frick. Okay, so these are all inputs. And this is our... The radio RX is a non-blocking X-bus input connected to a radio receiver. Data packet is received over the radio. Okay, when we receive a value, then we must... Wait, in that previous one, I assumed that we were receiving negative 999. But it seems like I probably didn't need to do the check for whether it was equal to 0. So the X bus would just not have a value? How does that work? Okay. But it says it's non-blocking though. How does that work? Now, what if I just test it? Okay, we have Rx is an X input. So we can read from X1. If you pull a non-blocking, it'll return negative 999. Oh, I see. So you do need to check whether it's equal to the value you expect. All right, so what do we want to do here? We want to read from radio Rx, so we want to move Rx. No, we want to check if Rx is equal to negative 1. S equal X1 is equal to negative 1. If it's not, you want to just go, right? You just want to go. But if it is equal to negative 1, then you want to transmit 3 data packets. First one is the X value, and then the Y value. Okay, so X and Y. Simple inputs, X and Y. Okay. X and Y. Where does this output to? This one? All right, we can use the X0 for output to TX. Okay, hold on. This one. How are we gonna wire this? This one's gotta go here, but then we gotta connect this one. Okay, let's move this entire thing over. So this one's gotta go here. No, this one's gotta go here. This goes here. This one goes here. Okay, so if we receive a negative 1, we want to move X, or not X, we want to move P0. We're writing X and then Y. Okay, so we're writing P0 to X0. We want to move P1 to X0. And then we want to write a value based on these. So we need something else to read these two values. So that goes there. But then how are we going to get that value into this? We don't have enough inputs for that. No, I guess this X could output to somewhere else. And then that thing can send it to Rx. Or we could just use a bigger one. I guess we could just use this. It's probably better to just use this one, right? A, B. Yeah, this has... That's not enough. That's not enough. We have 2 X inputs on this side. 2 X inputs on this side. No, these are simple inputs. Okay, so we can't do that. This is not enough simple inputs. Hold on, let me just check that this works at least. So we have nothing. We write 63 and 37, so that is expected. Let's learn how to use the multiplexer. There's a multiplexer? What do you mean? Multiplexer? Where? Let's equal the DX300. DX300? I don't even have that. Oh no, it is there, but it's not recommended. I also can't even use it. I can't. I haven't unlocked it yet. Oh wait, no, it's just because I'm in here. Okay. Oh, you can use it. Never mind, you can use it. But it says it's not recommended. What am I supposed to do? DX300. Control the world with the DX300 digital I/O expander. You can read or write up to 3 on-off signals at once. Okay. At any given time, DX300 is either in input mode or output mode. Getting an X bus value. Put its simple I/O pins into output mode. The specified output values. Reading will put the pins into input mode, clearing any previously set output values. It's either in input mode or output mode. So if any reads come in, they go to here. If any writes, what? Hold on. Writing an X bus value. We'll put its simple I/O pins into output mode. So these will be output mode. If these are outputs, then these are outputs. If we read, turns any X bus into 3 digital simple I/Os. Oh, okay. Oh. So that's kind of like what I was doing before, but manually, like one at a time. I see. That's what I was doing, but like I was writing like move and then sleep, whatever. I see. Interesting. Would that help me now? Because like my issue is that there are not enough. What was I trying to do here? I wanted to read from this. We had the X inputs. And then I wanted to... So this X output goes... So we want... What do we want to do? We wanted something to calculate this value, right? I guess we could just write this for now. So these are simple, A and B are simple inputs. So they can go into P0, P1. And then we want, what do we want to do with this one? 0 if A is 0 and B is 0. 1 if A is 100 and B is 100. 2 if A is 0 and B is 100. 3, okay. So EEQ P0 if P0 is 0, that means A is 0. Then we want to do something. What do we do with this? This is like the truth tables, right? Hold on. So like with truth tables, you have binary. So if A, we have A and B. Right. This is not valid syntax, but I'm just expressing values here. If A is 0, B is 0, then out is 0. If A is 1, B is 0, And output is 1. A is 0. I should reverse these. B should be here. A should be here. So this is just binary, right? This is there, and this is there. Then it should be 2, and then if they're both on, then it should be this. Okay, so does this help? Does this help at all? Is that even anything? Can we turn values into I don't know. What are our instructions? DGT. What is that? What's DGT? No. Okay, hold on, but we don't need to do that. We can just add. Good cat. Here's what we do. If T hold on. If P, okay, we'll set this to 0. Move 0 to accumulator. And then we want to, here's what I'll do. I will move, wait a second. I want to add P0. No, we want to add P1. Right? And then, wait, but then how do we do that? What am I doing? No. We have to... I would like to multiply what is here, but I can't do that without moving into add, right? This multiply takes... Oh, wait, no, hold on. It multiplies... and puts it... Okay, so we... I'm not making sense right now. We definitely want to add the A value. So P0. Oh, no, here's what we'll do. We'll add... we will add P1 and then multiply by 2. This is effectively a left shift by 1. If that makes any sense to anyone. And then we have to, then we add P0, and then we divide by 100. Yes. Is that a thing? Is division a thing? Invalid instruction? Is division not a thing? Oh, shoot. Division not a real instruction. No. Jump. Mul sub. No. I guess I could do this digit. I just want to take so with this one it'll be here, and I want to take digit of 2, digit 2, DGT2, right? So this will be the value. Yes, and then we want to move this to x0. Sleep one. Move back to x0. So this will be an output. But now we want to take 2 x inputs. We want to read from x1 twice, and then read from x0 once, and write that to Rx. How do I do that? We need a third thing. Let me move this over here. I'll move this here, right? And then move that there. I guess we could just move this here. Okay, so now, instead of this thing writing to Rx, we need to have two X inputs. Here, and I can't get that one over there. How am I gonna get this one over there? Could move this one more. Two more. Move that there. Move this here. And then we can move this one over. Okay, now we have this. And oh wait, but how are we gonna write? Okay, so we need to use this one. Okay. This one goes here, this one goes there. So all this one's gonna be... Wait, this doesn't work. Pin type mismatch? Part connected to itself? What are you talking about? No, it's not. This is going there. This is going here. How is that connected to itself? This is X2. The same wires hidden underneath. Oh, frick. I didn't know that. Okay, this goes there. What? Oh, it doesn't delete the wires for you. Wait, where did I have this go? This doesn't go there. This right, this goes up here. And this goes there, and then this goes there, and that goes there. Okay. So we want to move X0 to X3. Move X0 to X3. Move X2 to X3. Leave one. We probably need some no-ups in there. Something's probably wrong. Why can I not play paused? Something wrong here. Power usage, show profiler. Things here. Connect this one. What's wrong? Why? Show wires tab. That's fine, right? This is totally fine. That goes there. Oh wait, what the frick is this? What's that? Okay. Step. Okay, here we go. Part not sleeping, blocked on read. Part not sleeping, blocked on read. Part not sleeping, blocked on write. Okay. X and Y are simple inputs, and B are simple inputs. These are all simple inputs. And that's fine. You're writing two values. Let's step through this. Okay, first we're testing if x1 is equal to -1. It's not, so it should go to the next thing. Why is it writing something there? Why? Move x0. It shouldn't write something. Oh, we have to always write something. Otherwise, this will get blocked. But isn't that fine? Isn't it fine that that gets blocked? Let's go 0. This does nothing. Move 0 to X. Oh, because then this one has nothing. This one blocks on read. Is there a way to say to only have it return when requested? Okay, we could have this one always reading. These could always return -999 if there's nothing, right? Okay, so here's what we'll do. If it is not -1, we will move -999 to x0. Right. And then this one, we'll move x0 to ac, and then we'll test. If ac is equal to -999, then jump to next. Right, and then here we have next. Or not jump, JMP. So this thing will always be reading values. But we should also, if it is, we should also still read something from this. So we have to move. Hold on. If it is equal, we should move x2 to ac. Does that do anything? It doesn't do anything, but it doesn't matter. Okay, this should go. Right, 0. Moves. Oh, but then this one, wait, hold on. What? Part not saving blocked on right. Is the ordering messed up here? Hold on. This one. Let me reset this. Okay, we start here. Do this one. Test x1 is equal to -1. It is not. So it should go. It should move a value to x0. Wait, it should. Oh, I wrote the wrong thing. It should be. It should be x. Wait a second. I mixed up the ordering here. This should be Rx. This should be TX. Wait a second. What did I do? Why is this reading from there? Transmitter should go X3. Oh, hold on. Okay, I know. This thing should be writing there. And here, let's do this. This thing should be reading from Rx. So that goes there, and this goes there. I think that's it. Okay, we step, go here. This does its thing. It's not working. Why is it not working? Test of equals x1. x1. No. Wait, this should be x0. And then it should be writing to x1. Okay, this should be it. Maybe. Maybe. Okay, this is going there. It is not equal to -99. So it should write negative. No, it's not equal to -1. It should write to there. Okay. And then this is testing whether this thing is -99. And it is. So it should move. It should copy this value. Right, it's blocking, it goes over there. Copy the value. And then we jump to next. Sleep 1. Okay, now we have an actual value. So we move 63. We write it. We move this to there, we write 0. Okay, this is, look at that, that's going. And then we should read a value from here. And it is 0. Then we go. Continue to go. Let's just go. Hey, look at that. I got it. I know. Not even efficient. Actually, in fact, pretty bad. But it works. I think this part's clever though, right? You think people consider doing a binary addition of this thing? You think they did truth tables to determine? Probably. But the rest of this is wrong. I don't know what the heck I'm doing there. Alright, let me do this one. We're probably not going to finish this one in the next like 20 minutes. That could happen. Ammo. Laser tag equipment. Hit is a simple input connected to an array of laser sensors. Respawn is a simple input connected to a quick connect jack on a vest. Okay, this seems too complicated. I don't want to do this. This one's, yeah, I just by reading this, I'm like, I don't want to do this one. Let's do the next one. Cool Dad. Solitaire. I don't know Solitaire, though. I don't understand the rules of Solitaire. I guess I could do Solitaire, but I'm in this for the programming. Was this one simple? Radio RX is a non-blocking X-bus input connected to a radio receiver. Red, green, and blue are simple outputs connected to an ultra-bright RGB LED. Okay, when data packet is received over the radio, pulse the LED as specified. It's the vape. Is this controlling the LED of a vape? Okay, radio RX is non-blocking X-bus connected to a radio receiver. Radio RX. This is our receiver. Red, green, and blue are simple outputs connected to an ultra-bright LED. Okay, this is the LED. Red, green, and blue. When data packet is received, when we get something from RX, we write red intensity, green intensity, pulse duration. If a data packet is received while a pulse is in progress, interrupt the pulse. Okay, RGB and then duration. Duration goes possibly infinite. Okay. So we want to test connecting them so the vape LED synchronizes with the beat or the music. What the heck? Okay, so we have the radio RX. I'll put this up here. So what we want to do is we need to have 3 outputs though. Right? We need 3 simple outputs. So is this the one where we can use this thing? We have the 3 X outputs that go into simple outputs. But it says part not recommended. Why would they not recommend this? It seems like the perfect use case. Okay, so for this one, what do we gotta do? We got to X1, X2, and X3. X1 will go here, X2, X3. And then we have the pulses. It's gotta go this way. Oh no, hold on. Put this over there. This one here, that one over there. Okay. So, what do we want to do here? We want to move, okay, when we receive something from RX, move RX to ACK. Maybe we don't want that. Want to check if, I guess we do want to move to ACK. Move X0 to ACK. And if x0 is negative 999, do nothing. So we want to mark. So check if ACK is equal to negative 999, and if it is, move, jump to mark. But if it's not, then we want to read 3 values. Move x0. We want to write R, G, and B for some duration. Okay, we want to move x0 to x3. We want to move x0 to x2. Move x0 to x1. So this is R, G, and B. And then we have a duration. We want to move x0 to accumulator. And we want to count down, right? So we want to hold on. Wait a second. If you read from Rx twice, it'll just return the value, right? It doesn't. Okay, this is non-blocking, so we don't really need to move it into ACK. We can just test if x0 is equal to negative 999. And we can use ACK as a countdown. So, we do definitely want to decrement the counter. So I want to move x0. We're doing. We want to move. We want to subtract 1 from ACK. And if ACK is equal to 0, hold on. Have to go for a duration, right? We've got to go to this thing for 999. If ACK is 0, we want to set everything to 0. So I guess if this, hold on. If the input is not negative 999, it means we've received something. So we've received something. Then what do we want to do? We would like to, then we want to do all this stuff. Then we have it. If there's nothing, then we want to continue this. Then we want to stop. Okay. I want to check if accumulator, if ACK is equal to 0, then this. Test equal if ACK is 0. No, this should be above here. Test equal ACK 0. If ACK is 0, I want to move 0 into x3, x2, and x1. Is there a better way to do this? Welcome props.jack. Move 0 to x1. Otherwise, Sub 1. Okay, does this do something? Is this even anything? Shall we step? We advance. Okay, we receive 0. This is wrong. Everything here is wrong. One word of warning, the DX300 only does digital outputs. You only have the option of 0, 1, which you set by setting it a 3-bit value. What? DX300 does digital output. Wait, but what about if the digital is inputs? Oh, do you have to set... You have to like do some division to get this thing to... DX300. Oh, you have to... I see. Oh man, that's why they didn't recommend this. X plus value send 100. Yeah, you already could do that, true. Okay. Okay, so let's see. Let's see here. We don't want to move this directly there. You want to... Oh, we have no more space here. Problem is I need analog outputs. Do I? 100 P2. Stepper motor controller. Okay, so maybe I don't use this. Let's see, digital. Could write this there. Interesting. Interesting scenario we have here. 0. Yeah, we don't have enough instructions for this. If I wanted to do the DGT, DST. Man, all right. Well, we have these, and then we want to convert these to... They should have a part that just converts your X input to a P output. Could I just have like 3 different one of these? X to P. I guess I could use two of these. Oh wait, hold on. I could have one of these. This P could go directly to there. And then we could have the other 2 go through this one. Okay, so instead of X1, we have P1. P1 will go directly to here. And then the other ones will go through this one. So this one's gotta be like... Get these out of here. These ones have gotta be here. Hold on, we have P1. And we have... Okay, X1 has to go to... This is gonna be X1. This is X2. Okay, and then P0 has to go to here. How am I gonna do that? Here, we'll do this. We'll have X2 goes to X0. X3 goes to X1. And then P1 goes to... Wait. How do I get that over there? To move that. I don't have space. Okay, let me move this over one more. Then we move this over. And we move this over. This goes there. This goes there. Okay, now this goes here. All right, so x1, instead of x1, we write to p1. p1. Right, and then this one, all it's doing is taking x3, and x3 is this. Okay, so move x3 to p. What? Wait, something has to go here. Wait, hold on. This p0 has to go to this one. Ah, frick. Wait. How do I do that? No, no. How do I? Okay, hold on. I guess this p0 can go. You know what? I don't even need this one. I could just have this p0 go here. So instead of this, here we don't need this one. I guess we don't need this one either. Move from x3 to p1. Enough code for the 6000. I don't know. Hold on. First, we have to move x0 into. Okay, move that to x3. And x3, x0, sleep 1. And then this one will go to p0 and p1. This one goes to p0. Okay. And then all this one is doing is writing this. Does this work? It probably doesn't work. You write 0, you write 50. 9. Hey, something. Look at that. Red. Okay, red. R goes there. Let's reset this. P1. Writing. Oh, this should be P1. R is there. G goes to x3. Okay, p0. x3. Hold on. Gonna go here, we read those. What? What the frick? What did I do? From x0 right to p1. What? So it's not this. Because there, you write 0 to p0. Why am I writing to p0? This should be writing to... No, that's fine. p0 is there. Oh, this should be p0. No. This should be p0. RGB. So this is p0, this is p1. Okay. Go to this one. Right? No, what? Dude, what the heck? Short not sleeping. Locked on read. X0 to p1. What am I doing? Sleep 1. Part not sleeping. Blocked on read. We are always... Okay, so we have to always write something for this thing to be valid. So, it is that. Then we have to move -999 to x3. And then this one, we have to be like... move x0 to x. TQ. If ac is equal to -999. then it's not equal. No, you're raiding just as I'm literally gonna end my stream. Sorry. Hello raiders. Welcome, Kali Art. Let me shout you out. Kali Art. You're streaming art. Hope you had a good stream. Welcome, it's Kaz. Welcome, Pong. Welcome, Himori Copter. Welcome, Komogu. And Chocolate. Shrew. And Aoi Koneko. Yeah, I'm gonna end my stream soon, so sorry for the timing. I'm doing a programming stream. Welcome, Puriture as well. Alternatively, have the 4000 takes the RX input and have it processed that way. You're big fans of your small whole life art? Well, I'm glad you enjoy it. Hope you did some good art today, though. Hold on, this part is not blocked on right. What? The heck? Sorry, this stream probably makes no sense. If you don't know programming, and also even if you do know programming, this is still very confusing. But my Live 2D is stuck. It's not moving for some reason. Why is that? Oh, there it is. No, I'm not gonna spend another 30 minutes. Yeah, I don't know, I'm stuck. You know what? We're just gonna call it here. I could try to figure this out, but this will probably take a long time. And I don't really want to. So that'll be it. That's gonna be it for today's stream. That's cool. Anyway, fun game. A lot of reading of manuals. Programming. Alright. We're gonna call this stream now. We're gonna see what today is. We're gonna raid someone. National Laundry Day. Tax Day. It is in fact tax day. People that are in the US, make sure you do your taxes. Will I return to this game? I don't know, maybe. I mean, I did enjoy also Exapunks. That game was cool. McDonald's Day, Anime Day. What the? National Anime Day? Glazed Spiral Ham Day? Rubber Eraser Day, National That Sucks Day, Boston Day, Titanic Remembrance Day, World Art. Hey, World Art Day. You were doing art. We all know art. Let's do Tax Day. Tax Day Raid. And let's see who's streaming. Twitch.tv. Raid. What the frick? Ellis is streaming? She never streams at this time. Alright, let's raid Ellis. Exapunks is a bit more easier to understand for the uninitiated as a robot. Yeah, it's like you can see what's happening. Whereas like if you're playing this game, it's like, I don't know. Shenzhen, Iowa is based because that's what you chose for a career. Yeah, microcontroller program. That's cool. Anyway, that's cool. Wait, Ellis is not American though. It's not tax day for her. Whatever, it doesn't matter. Anyway, I'll be back on Wednesday for fishing. That's right, no stream Tuesday because I'll be in the office. And we'll have fishing, and then Thursday, no stream again. Friday, we got some Picross. And then Saturday, I can't talk. Saturday, we have various games. Anyway, thanks for stopping by. Thank you, Kali Art, for the raid as well. Hope everyone has a good rest of your day. And I will now sit here waiting for that raid to go. Sure is a thing. Good times. Just sitting here waiting for that raid to go. Yep, sure is happening. Okay, that raid's going. I will see you next time. Goodbye.